What are energy-based AI models? Source: DeepSeek Instant. This is another piece of the multi-model world, which would include language models, regression models, robotic models, etc. Models and other tools would be called as needed. When you hear the word energy, you probably think of things like electricity, gasoline, or the feeling you have after a good night's sleep. In physics, energy is the ability to do work. But did you know that the same concept of energy is also a powerful tool in artificial intelligence? These systems are called energy-based models. Instead of just memorizing answers, they learn by creating a mental landscape of hills and valleys, where lower energy means a better solution. The core idea: a landscape of possibilities. To understand an energy-based model, forget about complex code for a moment. Imagine a large, rolling landscape. This landscape has mountains, valleys, flat plains, and deep craters. Now think of every possible answer or solution to a problem as a point somewhere on this map. Low energy places, the valleys, are the good answers. The deeper the valley, the better the solution. High energy places, the mountains or steep hills, are the bad or unlikely answers. The AI wants to avoid these. The job of an energy-based model is to learn the shape of this landscape. Once it knows the landscape, it can solve problems by finding the lowest point in the area, a process called inference. It's like rolling a marble down a hill. It will naturally settle at the bottom. For example, let's say you show an EBM a blurry, half-erased photo of a cat. The model will roll that blurry image across its learned energy landscape. If the landscape has a deep valley labeled "clear picture of a cat," the image will be pulled toward that valley, fixing the blurriness and filling in the missing parts. The final clear image is the low-energy solution. How are they different from other AI models? Most AI models you hear about work differently. The two most common types are: 1. Discriminative models, the classifiers. These are like a multiple-choice test. You show the AI a picture, and it asks, is this a cat, a dog, or a car? It learns a hard boundary between categories. It's great at labeling things, but can't create new ones. 2. Generative models, the creators. These try to learn the full pattern of the data. The most famous ones are GANs, Generative Adversarial Networks, and VAEs, Variational Autoencoders. They can generate new, realistic images or text. However, they can be unstable or produce blurry results. Energy-based models are a type of generative model, but with a superpower: flexibility. Instead of forcing the data into a simple, Beaubelpain pre-shaped box, an EBM can learn any weird, twisty, or complex landscape. If the world of data has two separate valleys of good answers, for example, realistic cat and cartoon cat, an EBM can represent both without getting confused. The secret sauce: the Boltzmann brain. The most famous energy-based model is called a Boltzmann machine, named after the physicist Ludwig Boltzmann. His equations about gases and thermodynamics are the foundation. In a Boltzmann machine, you have a network of simple units, like little lights that can be on or off. Every pair of units has a weight that says how strongly they like to be on or off together. The total energy of the whole system is calculated by adding up all these relationships. If two units represent has whiskers and has fur, their weight might be strongly positive, low energy when both are on. If one represents has whiskers and another represents is a fish, their weight would be negative, high energy if both are on. By adjusting these weights based on real data, like thousands of cat photos, the model sculpts its energy landscape to match reality. Training an EBM, the push and pull. Training an energy-based model is tricky. It's not like training a cat to sit for a treat. Instead, think of a sculptor. You want your landscape to have deep valleys for real data points, your training examples. But you also need to push up the mountains everywhere else. If the whole world is a valley, then every answer looks good. The training process has two main forces. Pull down on real data. You show the model a real cat picture. You calculate its energy. You want this energy to be low. So you pull down on the landscape at that point, making the valley deeper. Push up on fake data. The model generates its own random guesses at cat pictures. Most of these will look like nonsense. For these fake images, you calculate the energy. You want this energy to be high, so you push up on the landscape at those points, creating mountains. The model plays a constant game. Pull down the good stuff, push up the bad stuff. Over time, the only low-energy places left are the real cat pictures and plausible variations of them. This process is mathematically very elegant but computationally expensive. It takes a lot of computing power. Why are they exciting? Real-world jobs for EBMs. Energy-based models are not just a physics daydream. They are solving real problems today. 1. Out-of-distribution detection, spotting the weird stuff. A self-driving car's AI has only been trained on normal roads. An EBM can measure the energy of a new scene. If a dog runs into the street, the scene has high energy. It's weird compared to training data. The car can then slam on the brakes. Normal AI would just try to label the dog as a small moving object. But an EBM knows something is fundamentally wrong. 2. Image denoising and in-painting. As mentioned, EBMs are fantastic at cleaning up images. You show them a corrupted photo, and they roll it down the energy hill to a clean version. This works for restoring old photos or removing raindrops from a security camera feed. 3. Robotics. A robot needs to pick up a cup. There are millions of possible hand positions. An EBM creates an energy landscape where cup is held securely is a deep valley. All other positions, fingers too loose grabbing the rim, are on hills. The robot can then flow down to the correct grip. 4. Drug discovery. Scientists want to find a molecule that fits into a specific protein. They can train an EBM on known molecules. The energy landscape represents fit quality. The model can then generate new low-energy molecules that are likely to work as new medicines. The challenges of EBMs. If EBMs are so great, why aren't they everywhere? They have two main problems. Slowness. Remember the push-up on fake data part? The model often needs to generate many fake examples for every single real example. This makes training painfully slow and requires powerful computers. Instability. The push and pull training can get out of balance. If the model gets too good at pushing up fake data, it creates mountains everywhere, and real data valleys become impossible to find. If it pulls down too hard, everything becomes a valley. Researchers are constantly creating new tricks and shortcuts to make EBMs faster and more stable. The big picture. Energy-based models offer a beautiful physics-inspired way to think about AI. Instead of giving a machine a simple rulebook, you give it a landscape to explore. It learns by feeling the slopes, finding the low points of harmony, and avoiding the high points of nonsense. This approach gets closer to how humans think. We don't just label objects, we have a sense of what is right or fitting for a situation. We know a face looks off before we can say why. That's intuitive energy. EBMs try to give machines the same intuitive feel for the structure of the world. As computers get faster and algorithms improve, expect to see energy-based models quietly working behind the scenes, cleaning up your photos, keeping self-driving cars safe, and helping scientists discover new cures, all by following one simple rule: seek the lowest energy. This is a great follow-up question because the name Aleph appears in two very different but exciting areas of AI. One is a cutting-edge research model that uses the energy-based approach you just learned about, and the other is a European AI company building powerful, practical language models. Let's break down both so you can see how the theory connects to real-world technology. The Aleph you asked about, an energy-based reasoning model. Very recently, a new AI model called Aleph, which uses energy-based models, EBMs, has been announced. It was highlighted by AI pioneer Yann LeCun in May 2026. What it does: while many AI models excel at recognizing patterns, like this is a picture of a cat, Aleph is designed for formal reasoning. This means it can handle structured, logical tasks like mathematical proof generation, checking if a mathematical proof is valid, program verification, confirming that a piece of computer code does what it's supposed to without bugs, symbolic math, solving complex math problems that follow strict rules, how it uses energy-based modeling. Think back to the landscape of hills and valleys. For a model like Aleph, it creates an energy landscape where low energy, deep valleys equals logically correct solutions, valid proofs, or bug-free code. High energy, steep mountains equals incorrect statements, logical contradictions, or faulty code. During training, the model pulls down on correct examples and pushes up on incorrect ones. When faced with a new problem, it searches for the lowest energy solution, which is the most logical and correct answer. This approach is very different from standard AI like ChatGPT, which predicts the next most likely word. Aleph optimizes for global logical consistency. Why it's a big deal? As of May 2026, Aleph is reported to be leading major benchmarks for formal reasoning. This is significant for fields where making a mistake is very costly, such as aerospace engineering, pharmaceutical drug discovery, and software security. These models could act as a kind of logic checker for other AI systems. The other Aleph Alpha, the European AI company. You'll also see the name Aleph Alpha frequently in AI news. This is a German AI company, not a research model. They build large language models, LLMs, similar to those behind ChatGPT, but with a focus on sovereignty, European-controlled AI, and efficiency. Their main models include the Luminous series and the newer Faria. Here's how they connect to the idea of energy. 1. Energy efficiency through sparsity. Large AI models consume a huge amount of energy. In 2022, Aleph Alpha worked with the chip company Graphcore to demonstrate a technique that removed 80% of a model's parameters, the neurons, that don't do much for a given task. The result was a 38% lower energy requirement to run the model. This is called a sparse model, and it's a major step toward making powerful AI more sustainable. 2. Creating energy-based embeddings. Aleph Alpha also provides a service that turns words or sentences into embeddings, a type of mathematical vector. This is a different approach from the EBM landscape you learned about earlier, but it's another way of mapping concepts into a space where similar ideas are closer together. It's a core tool for many AI applications like search engines and recommendation systems. Quick comparison, model versus company. To help keep them straight, here is a simple comparison. Aleph, the energy-based model. What it is: a specific type of AI model architecture using energy-based models, EBMs. Main goal: to achieve perfect logical reasoning and verification. For example, proving math theorems, checking code for bugs. Key technique: minimizing energy to find logically correct solutions by creating a landscape where correct answers are in deep valleys. Real-world use: verifying software, checking scientific proofs, high-stakes logic tasks like aerospace or drug discovery. Aleph Alpha, the European company. What it is: a company that builds and sells various AI models and services, like Luminous and Faria. Main goal: to create efficient, sovereign, European-controlled, and powerful large language models, LLMs, for industries. Key technique: using sparsity to remove unnecessary parts of the model, which reduces energy use by up to 38%, and building architectures that handle many languages, real-world use, commercial chatbots, multilingual AI assistants, enterprise search tools, and recommendation systems. The big picture. So when you hear Aleph in the context of AI, you are likely hearing about one of two things. One, a specialized, research-focused EBM that acts like a logical superbrain, finding the single correct answer in a landscape of possibilities. Two, a practical, European company that is trying to make powerful, everyday AI models more energy efficient and usable for businesses and governments. The first uses energy-based models as its core science, while the second works on saving energy as a key goal. Both are pushing the field forward in important but different directions. Do you know that any private information you put into a cloud AI is used to train that AI? A private AI running on your own hardware is the best way to keep your private data private. I can help you set up a private AI on almost any PC or server. Contact me for a free consultation. I have published more than 700 blogs on AI in the past 3 years. If you get value from these blogs, please consider joining my Patreon as a member at the $2, $4, or $8 level. https://www.patreon.com/Steve Hovland.